Hello and welcome to Mr. Thompson's Math Tutorials. Today we're going to talk about division. I'm going to teach you the standard algorithm for division, and I often refer to it as this. I often refer to it as dad, mother, sister, brother, which stands for divide, multiply, subtract, bring down. But I'm also going to attempt to explain why it works. So let's start with the standard algorithm, and let's just divide these two numbers here. Again, with any division problem, I'm really asking how many 3's are in 78. So to set up the standard algorithm, what you do is you put the divisor, which is 3, outside this little symbol, and the dividend, which is 7, inside the symbol. Now, what I'm going to do is I'm going to start by asking myself how many 3's are in 7. But really, the question I'm really asking is how many 3's are in 7D. This 7 is actually a 70, not a 7. So I'm really asking the question of how many 3's are in 70. But this algorithm is efficient because you're not dividing by the number of 3's in 70. You're really looking at that 7. So I ask myself how many 3's are in 7. And the answer is there are 2. That's my divide. That's my D. Now I'm going to do the M, which is multiply. I'm going to multiply 2 times 3, which is 6. Now this 6 is actually not a 6. It really represents a 6D. Okay, but I'm not going to write the 60. I'm just going to go from there. Okay. Now I do the next step. I've done my multiply. I'm going to do my subtract. I do 7 minus 6, which is 1. This 1 is actually not a 1, it's really a 10. All of this is in the tens column here. You can see this is actually the tens place. Okay, now what I'm going to do is bring down this 8. So I bring down this 8 to here. Once I've done that, once I've brought down, I go all the way back to the beginning. So again, I'm going to start with divide. How many 3's are in 18? There are 6 3's in 18. 6 times 3 is 18. I subtract, I get a 0. And there's nothing left to bring down, so I can see that the number of 3's in 78 is 26. Now, conceptually, really what I'm doing is I'm breaking apart this 78. 78 is actually equal to 60 plus 18. So if I divide 78, this means 78 divided by 3. It's really the same as dividing 60 by 3 and 18 by 3. And you can see that that's really what this algorithm is showing us. This algorithm is really showing us that we've broken apart the 78. We found out the number of 3's in 60, which happens to be 20. That's represented by this 2 up here. And the number of 3's in 18, which is 6, and that's represented by the 6 right here. When I add those two together, I get 26. So this is, this is another way that you can solve these kinds of problems, is breaking them apart and dividing the parts and then adding at the end. But the standard algorithm is quite efficient for other methods, as a method. Okay, so let's scroll down and look at a different example. So I want to look at this particular problem. So we are looking at how many 5's are in 624. Again, it's how many of these are in that. I'm going to use the standard algorithm, and then we'll look at how that works. So here we go. We'll look at a conceptual model also. Okay, so standard algorithm would have us do this. It would say put the 624 inside the symbol, the 5 goes outside, this is the divisor, that's the dividend, and then I start with my dad, mother, sister, brother. So I'm going to start with my divide. How many 5's are in 6? There are 1. Now really, again, I'm asking how many 5's are in 600, and there are 100 of those. 1 times 5 is 5, but this 5 is actually not a 5, it's a 500. I subtract, I get a 1. I bring down my 2. And now this 12 that you're looking at here actually represents 120. It's got a 100, it's got a 20, it's got nothing in the ones column. This is 120. How many 5's are in 12? Well, the number of 5's in 12 are 2. 2 times 5 is 10. I subtract. I get a 2, and I bring down my 4. How many 5s are in 24? Well, the number of 5s in 24 is 4. 4 times 5 is 20. I subtract, I get a 4. Now, at this point in the past, you might have written this as 124 with a remainder of 4, but I no longer want us to do that. I want us to continue to divide, and we can. We can actually add a 0. To do that, I'm going to add a decimal here, and I'm going to add a decimal in my quotient and put a 0. And then I'm just going to bring that down. Now, how many 5s are in, oh, sorry, why did I put an 8? How many 5s are in 40? Well, the answer is 8, and now I know why I put an 8 there. Okay, so 8 times 5 is 40. I subtract, and I get a 0. And then I can see that this is actually 124.8, or 8/10. Okay, let's look at this conceptually. Again, I could break up 624 into this. I know that 624 is actually equal to 500 plus 120 plus 4. Now, if I divide each of these by 5, it would be the same as dividing 624 by 5. And I'm going to get roughly the same thing. Not roughly, I'll get the exact same thing. How many 5s are in 500? Right, I'm dividing 500 by 5. Well, there's 100. How many 5s are in 120? Well, there are 24. Now, how many 5s are in 4? Well, I can't do that, but I could make this into a decimal by first converting it into tenths. So I can see that 4/5 is equal to 8/10. I'm multiplying times 2 times 2. Well, I could rewrite this then as 100 plus 24 plus 8/10. And then when I add this all together, I end up with 124 and 8/10. Okay, so the standard algorithm is really sort of mimicking this process right here. Okay, let's look at one more example of this. All right, here's a bit of a bigger one here, but let's get started on it. First things first, I'm going to write my divisor on the outside of the symbol. I'm going to put my dividend inside the symbol. Okay, so again, I'm going to ask how many 12s are in 9? Well, the answer is 0. There are no 12s in 9. So I'm going to then multiply. 0 times 12 is 0. I subtract, I get a 9. And then I'm going to bring down my 4. How many 12s are in 94? Well, there are 7 12s in 94. 7 times 12 is 84. I subtract, I get a 10. I'm going to bring down my 2. How many 12s are in 102? Well, there are 8. 8 times 12 is 96. I subtract, I end up with a 6. I bring down this 4. How many 12s are in 64? There are 5. 5 times 12 is 60. I subtract, I get a 4. Now, again, I'm going to add a decimal in my dividend. I'm going to add a decimal in my quotient. I'm going to add a 0, and I'm going to bring down this 0. How many 12s are in 40? Well, there are 3. 3 times 12 is 36. I subtract, I get a 4. I add a 0. I bring it down. I can see again that there's how many 12s are in 40? Well, there are 3. And I should start to notice a pattern here that when I subtract, I keep ending up with a 4. And so this tells me that what I've got here is a recurring decimal. I'm going to represent that recurring decimal with a line. So this is 785 and 3 repeating. I can ignore this first 0. If I was to do this conceptually, it would be quite a lot of work, so I'm not going to do it. But again, you would be looking at how many 12s are in 9,400, and then how many 12s are in 1,020, and then how many 12s are in 64, and then how many 12s are in 4, and kind of work your way down that way, and you would end up with this. Thanks for watching.